So, guys, let's have your focus here, please. I don't think it's going to take very long to go through this lesson. You know, this particular chapter, I could see a scenario under which we race through it, but I'd rather not do that. I'd rather go very methodical, very step by step, make sure we understand things, come back and spiral to them several times, and then progress a little bit forward. Just so you have a clue what's going on, we have lessons this week, obviously, and then after this week, next week, we have some more lessons on data. We've been doing data. We're going to continue to do data. And then we're pretty much done with the course. At that point, we're going to hit a couple of odd, isolated topics that don't seem to fit anywhere. And on May 29th, that's the Friday after Memorial Day, we have a test. There will be no relearn packet for that one. And then after that, we will get started on Regents Review. So, we're coming down to the end here, and I don't want to just rush through. This is not the most heavily tested stuff on the Regents. The quadratics are very heavily tested. Functions are super, super, super important on the Regents. This is somewhat less important, but it's still probably going to add up to around 15 points on the Regents exam. So we want to make sure we're able to get this right, and I'm afraid that if we don't take our time with it, we can botch it. So we're going to avoid that. Consider the following scenario. Transportation collects data on flight delays, blah, blah, blah. Consider the dot plot. Okay, so we have this dot plot, and it shows data. Come on, what are we doing here? Shows data on these flights. Oh, why is this not doing this? It did work now? Okay, good. How many flights left 60 or more minutes late? I think it's 16, am I right about that?
Yes.
Yeah, we did that with the last class. All you have to do is add up the number of dots over here, and you come up with it. Now, why is the data distribution considered skewed? How do you tell if something is skewed? Go ahead.
There's a tail too.
If there's a tail, that's one way to look at it. The definition that they would tell you in the book is a different way of looking at the same exact definition. First off, the tail is basically this area over here with red. But they say if the shape of the data is a mound or a double mound, if it looks symmetric vertically, then the data is not skewed with respect to the whole graph. But if you split this graph here, isn't it obvious one side has a lot more than the other side?
Yes.
Now, we would say that this is skewed to the right. The reason we say that this is to the right, we've been over this a couple of times, is these numbers on the right, these isolated few numbers, take whatever the balance point would be here, whatever the mean is, the median, and it pulls it to the right. Now, to skew means to change. I don't know if you've ever been in Home Depot or PC Richard. I bought a dryer from PC Richard a few years ago. It was normally a $750 dryer. I got it for $350. I walked through the door. There was a dent in the back of the dryer. Apparently, they tried to deliver it to somebody. They dented it when they went to deliver it. It doesn't affect the performance or anything, but the people didn't want it. So I said, how much do you want? And they said, we'll charge you $350. I said, $400 saved? Bam, done. I bought the dryer. When you get to the front, they say that the cashier, they'll say, oh, I need a manager. I have a skew. And what a skew means is a change. So the balance point or the center point has changed in the mounded area. And how has it changed? It's moved a little to the right because of all of these points in the tail here. So the tail pulls the center point or the balance point toward itself. So if the tail is on the right, it changes to the right. Remember that skewed means changed, so it's skewed to the right. If the diagram was reversed and on the right-hand side you had all the data and the tail on the left, it would be sliding that balance point to the left, okay? So whatever side the tail is on is what you're skewing to. Is the Taylor distribution to the right or the left? The tail is to the right, and how would you describe several delay times in the tail? Pretty long, all right? 120-minute delay is going to annoy me. Any questions about that?
No.
Okay, so this data stuff to me is not difficult. It's almost like sitting in social studies class and just looking at DBQs. And these are, in my mind, kind of a mathematical DBQ. You look at the information and you try to draw conclusions. Then it says to draw a box plot for the about the dot plots. We're not going to do that. We're not going to do that because there's like 100 dot plots on the other thing, and I don't want to put that much information in the calculator. So I'm going to make up 11 times. And you're going to put them in, and you're going to draw a box plot on this. Ready? Those are 11 times. You're going to put those 11 numbers in a list, and then you're going to draw a box plot on the thing. And then answer the first question about what you think the interquartile range is.
You use the bottom ones, right?
What do you mean, the bottom ones? Oh, for the box plot, yeah, you got to scroll through down to the bottom, because you need the quartiles. Quinn, you still got that phone? Just making sure. Mom drove like a maniac through the parking lot last night. Did you notice that? I hope Mom's listening to this. She could have clipped a couple of kids, sent them flying. You should go home and ask your mom if she's ever seen Death Race 2000. Death Race 2000, the original, where they put the old people out and they drive through and they run them over and they go flying over the car and they get points for the dead people.
Wow, that's ridiculous.
That's the Death Race. The more people you kill, the more points you get.
What do you get if you get the most points?
Oh, I don't know, some super award, but it was kind of like Mrs. Duarte, well, no, let's see. Mrs. Boble was very much like
What? How is she?
Frankenstein in Death Race 2000.
What'd she?
Oh, she came ripping through that parking lot. You know what I'm talking about.
She
don't you?
wanted to see Quinn hit a home run.
No, she wanted to get Quinn's phone and get home.
Oh.
Yeah, she left it at school. Well, and then I said, a young lady separated from her phone is really bad. She goes, Quinn loses it all the time. All right. So there are 5 important points in this. Come on now.
It worked. It worked. It worked.
Okay. There are 5 important points in this. The minimum, which is what? 0.
0.
First quartile, which is
10.
what?
10.
All right. Then we got the median, which is also known as the second quartile. What's that?
20.
And then we got the third quartile.
20. 35.
35.
Yeah, 35.
And then we have the max.
45.
Okay. So now I go over here and I go draw this thing out. Minimum is 0. Quartile 1 is 10. A median is 20. The next one's 35. And the maximum is 45.
Wait, but 20 isn't the middle.
What's that?
20 isn't the middle.
Here's the thing. It's not the middle of the distance. It's the middle of the scores.
That's right.
If I list all of these scores from least to
Just might be
greatest,
wrong.
there's a total of 11 scores. So the 6th score will be the one in the middle. Do you agree?
Check the numbers.
1, 2, 3, 4,
You've got 15.
5. There's my 6th score. 20 is the one in the middle.
Okay.
All right? Now, what this means is when we draw this chart, 25% of the scores are in this range, 25% in here, 25 here, and 25 here. In other words, 25% are between the minimum and the first quartile. Now think about it. Quartile, doesn't it sound like quarter?
Yes.
And a quarter is 1/4, and 1/4 is 25%. So 25% can be found here, 25 here, 25 here, and 25 here. So what percent of the scores is found between the first and third quartiles? Between the first and third quartiles, 50%. And that leads to this very important, often tested concept called interquartile range. Now, to me, you don't even need to be a math student to get this right. You need to be a student of the English language. Inter means between, like intergalactic travel between galaxies. Inter is between, quartile, range. Now, in statistics, the context of range is highest minus lowest. So they want you to figure out what the third quartile is, the first quartile, and as you do with range and statistics, you subtract. So what's the third quartile? 35. And what's the first quartile?
10.
10. If I subtract, I get 25. So that is my interquartile range. Okay? Any questions on that? All right.
You said the first to third is 50.
It is. 50% of the scores are contained between here and here. Yes, that's true.
Wouldn't it be 75%?
No.
First to third?
25% are here,
Yeah.
50% are here, and 25% are there. You can only add up to 100%.
I know.
So if there's 25 here and 25 here, that's, you gotta take 50 away.
But what do you mean first and third?
First quartile is this point right here. The third quartile is this point right here. So the question is, what percent of the scores can be found between here and here? Look, from here to the median is 25,
I didn't know
right?
that was a... Okay, I get it.
Okay, we're good? Excellent. I'll chalk that up to the effects of the heat that you're suffering through right now. Okay? All right, now, next up. Let's go to the next one. Now, here's where, again, to me, we're kind of doing more DBQ questions that have a touch of math to them than we really are doing legitimate, solid math. So here's the deal. They make up a couple of histograms. One histogram is for people in Kenya, one histogram is for people in the United States of America, and they want you to compare these histograms. Now, it's important that you realize, because with the other class, it took me a second to catch on to this, that the numbers on the left are percents, okay? And on the bottom is the age of the people. So, they're going to ask us some questions about, or that compares the data represented in these two histograms. First off, again, a very non-mathematical question, how do the shapes of the two histograms differ? I know, these questions you almost don't know how to answer them. It's like you're more afraid of making a mistake. Nolan?
One's more even?
Yeah, I would say one is more balanced, if you will, more even, and that would be the ages in the US. On the other hand, in Kenya, are the ages balanced?
No.
No, not at all. Clearly, there's a lot more young people in Kenya than there are, proportionally or percentage-wise, than there are in America. How do the shapes of the two histograms differ? We went through that. Now, approximately what percent of the people in Kenya are between 0 and 10 years old? So here is 0 to 10 on our chart. 0 to 10 is right here. Now, this looks to me to be about 15%, and this looks to me, 17, I'm sorry. And this one here looks to be about 15. So 17 and 15, I would say 32% in Kenya. Now, and the next one is United States between 0 and 10. And this to me looks like 6.5, and the next one looks like about 6.5. So altogether, that would be about 13%. And clearly, that's a significant amount, okay? 32% of the Kenyan population is under 10 years old, or 10 or under, and in the United States it's 13%. Very significant difference between the two, okay? What's the next question down, say, number 6?
Approximately what percent of people in Kenya are 60 years or older?
Okay, so 60 or older would be this part of the chart. I'm thinking that this here is about 1, come on, what are we doing?
2.
1, put these together, you get 1 plus that. I would say
1.5?
1, 2, like maybe 3 to 3.5%, something like that, maybe. You know, it's tough to tell exactly, but 3 to 3.5%. Did they say like approximately?
Yeah.
So, all right, then that's okay. And what's the last one say?
Approximately what percent of people in the U.S. are 60 years or older?
All right, so 60 years or over. So I'm looking here at about 5.5. Here I'm looking at about 4. Here I'm looking at about 3. I'll call both of these 2.5 times 2, which is 5. And then these guys here, I would put all together at about 2. So let's see, we got 5.5, 9.5, 12.5, 17.5, about 19.5, give or take. Maybe you said 18, maybe you said 20, whatever. Bottom line is, there's a significant difference, isn't there? Right? And now here's where, to me, it gets a little sketchy about being mathematical, but they're liable to ask a question like, if this was on part 2, the last question would be, why do you think there's such a discrepancy in the number of older people in the U.S. versus Kenya? Oh, I think there's some very easy reasons.
Because since people in US are fatter, they can lose
Live
weight.
longer? I don't
Yes.
think so. Generally speaking, fatter dies. Go ahead.
In America, we have less starvation than disease.
That's a definite starvation,
It's
disease,
just all
pestilence.
like,
Right, that's what's frustrating about it. I agree. Come on, more. Go ahead.
Oh, we have fresh water here.
Fresh water, good. You guys are learning everything except the most important answer right now. It's like they're giving you all these social huggy-wuggy things in class, but they're not hitting you with the biggest one America has that they don't have.
Medicine?
Medicine!
I said disease.
Yeah, but we have the disease. They may or may not have more disease, I don't know. But they died from their disease, and they died from their disease because we have medicine to fight the disease. I think if you're living in a hut in Africa and you have a heart attack, you're done. There's nothing you're gonna do. You're gonna. But if you do that in America, there's an ambulance at your house in 8 minutes, and they say something like if they catch a heart attack in the first 90 minutes or something, then they can do something about it. They can get you to survive.
I think we should have more hospitals.
More hospitals. Why?
We should have better doctors.
Because there's lots of hospitals.
I feel like there's only one in Patchogue. No, there's one in Powell.
Okay,
In Patchogue, which is a
a
tiny
hospital in Patchogue. They don't have hospitals in countries.
Well-
I mean, I'm sure they have a few hospitals in Kenya, but they don't have roads, let alone hospitals.
I think we
Maybe
should
they
have
should
more
first make
hospitals
roads.
in rural areas. Because, like, what if, yeah,
What if what?
in rural areas, they should have more hospitals.
What if you get run over by a tractor?
Well,
What's gonna
what they
happen?
do is they if you're in Africa, they have the Peace Corps come to the village. And look, the bottom line is it's all about money. Hospitals don't exist for free. It costs money to run a hospital. And you can't put a hospital where people can't get to it. If you went to the middle of Africa, the middle of Alaska, forget Africa, go to the middle of Alaska. You know how hard it is to commute around Alaska?
Nobody lives there.
No, there are people who do live there, but most of them actually fly. They have
Oh,
bush
yeah.
planes and they fly from place to place to place. That's a very difficult thing on a hospital, to put a hospital up there. So that's when you go there, that's part of the concern. When I talked to a friend of mine about where I would like to retire to, and he was telling me, well, these are the things you really want to consider. And, you know, I was talking about some pretty remote places. And my initial reaction was, if you go to these remote places, like if you go to upstate New York, or if you go to Montana or any of these places, people live long lives. And a big part of the reason is because there's less stress there. But he said, Bob, you got to go where there's medical care. So, like, we looked at Tennessee, but much of the state of Tennessee is not, it's very rural, and there's not advanced medical care. But the northeast corner, there's a lot of colleges, a lot of universities. It's called the Tri-Cities area. And it's very, very advanced medically. So he said that's where you go live, because when you are 60, 70, 80 years old, you need to see doctors. It's not like when you're a kid and you never need to see a doctor.
you should live in Boston.
I don't want to live in Boston.
You should live
You
in
know that
Maine.
snow?
I don't, see, Maine would appeal to me, because it's not congested, it's free. But my wife would never live in Maine. She, too cold winter. Cold winter, she don't want any part of it.
What about like the bottom of Maine or like Vermont?
My wife has Ichnade.